Bambu Lab P1S is a lower cost 3D printer compared to the Bambu Lab X1C. But is it a better value? That's what we're going to find out in this video. The two Bambu Lab printers have more in common than they have differences. However, there are some important differences that we need to discuss. Hi, I'm Ken of Wrist Innovations, and today let's compare everything about the Bambu Lab P1S and X1C 3D printers so you can make an informed decision on which one to buy if you are considering these printers. I have organized the video into chapters listed in the description that will allow you to skip around the video depending on what is important to you. First, I jump right into comparing the print quality of both printers because I think that's the most important thing to consider when making a buying decision. Next, I will cover the key features of each printer and point out what they have in common as well as their differences. Then, I will compare the unboxing and setup of both printers, followed by comparing the cost of both printers. Lastly, I'll provide my final summary and recommendations. I just want to mention that I bought both the P1S and the X1C with my own money. Okay, so let's get started. I printed parts on both the P1S and the X1C using PLA, PETG, the new TPU for AMS, ABS glass filled, and even nylon carbon filled. And I think you're going to be surprised at the results. I did upgrade the P1S with a hardened steel nozzle and extruder so that I could print the glass filled and carbon filled materials. But I'll cover that later in this video. I use Bambu Lab filaments for all my tests, especially since the print profiles are tuned for the Bambu Lab filaments. But in the past, I've used many manufacturers' filaments on my X1C because I've had that for over a year and a half. However, I've only owned the P1S for a short time. I know this isn't a big challenge, but first I printed a benchy designed by Creative Tools in PLA on both printers. The X1C benchy turned out great as expected. The P1S benchy also turned out great. There are a few stringers, but other than that, it looked just as good as the X1C benchy. I also printed this calibration test by Gabox 3D on printables using the same PLA. For the X1C, the overhang test results indicate that there was a slight issue at 60 degrees, but it did successfully print all the way to 80 degrees. The various cylinder diameters measured 9.85 millimeters, 7.78 millimeters, 5.80 millimeters, and 4.01 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters, respectively. The various rectangle lengths measured 10.11 millimeters, 20 millimeters, and 29.89 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters, respectively. Bridging overall looked good, and there were only a few stringers on the part. For the P1S, the overhang test results were actually slightly better than the X1C, and it did successfully print all the way to 80 degrees. The various cylinder diameters measured 9.83 millimeters, 7.84 millimeters, 5.84 millimeters, and 4.02 millimeters versus the design diameters of 10, 8, 6, and 4 millimeters respectively. The various rectangle lengths measured 9.98 millimeters, 19.98 millimeters, and 29.87 millimeters for design lengths of 10, 20, and 30 millimeters respectively. Bridging overall looked good, and there were only a few more stringers on the P1S part versus the X1C part. Overall, I consider both calibration parts to be essentially the same quality and accuracy. If you have a 3D printing need, but you don't have a 3D printer, I have a solution for you. That brings me to the sponsor of today's video, PCBWay. If you are working on any prototype projects, they can help you when you need a variety of parts. They have a large amount of resources to provide all your PCB needs. They can provide just the PCB or even fully populated PCBs. Besides making PCBs, they also offer CNC machining, sheet metal fabrication, injection molding, and lots of different types of 3D printing, including metal printing. And right now, PCBWay is having their Christmas sale offering up to 50% savings from December 12th to December 31st, 2024. You just need to go on their website, upload your design, select the material and quantity, and you'll get an instant quote. Next, their engineering team will review and approve the quote, and as soon as PCBWay receives payment, they'll manufacture your parts and ship them right to your door. Give them a try, and I think you'll be amazed at what they can do for you. I have a link in the description below. Now, back to the show. Next, I printed a business card holder designed by Chris Aero Engineering on printables using PETG or PETG. The X1C part turned out beautiful. There is an interesting pattern that the light reflects on the side of the holder, and it's on both sides. The P1S part also turned out great. It also shows the same pattern on the sides of the card holder, depending on how the light reflects. Overall, I can't tell a difference between the two parts regarding quality. This TPU is a new material from Bambu Lab that is compatible with their AMS, which is their automated material system that feeds filament into the printer. Previous TPU had to be loaded manually because it didn't work in the AMS. This new filament is stiffer than the normal TPU, so let's see how it prints. For the X1C, I printed 10 pieces of these tracks for a death racer that I will be building shortly. The Death Racer project is a joint effort between Michael Baddeley and Sam Prentice of the Real Sam Prentice YouTube channel. Links are in the description below. I was pleasantly surprised that there was little to no stringing with this new TPU material. The quality of the parts from the X1C turned out great. However, they are a bit stiffer than the standard TPU material that I'm familiar with. For the P1S, the parts also turned out great. Again, little to no stringing, and the quality is beautiful. I can't tell the difference in quality between the X1C and the P1S TPU parts. They are both flawless. Okay, now let's step up our game with a more challenging material, ABS. ABS can be a challenge because it tends to easily warp when printing because it really needs a warm environment. I decided to print this pipe wrench designed by 3dprintedhardware.com. For the X1C, the wrench turned out excellent. The main body, hook jaw, and nut all printed without any warping. For the P1S, I had the identical results with no warping of any of the parts, and everything fit together perfectly. Once again, I couldn't tell a difference in the quality between the two prints. Okay, now let's get wild and crazy and print some ABS glass-filled filament. Although the glass fibers should help with warping, they can be abrasive to stainless steel extruders and nozzles. So, for the P1S that ships with the stainless steel parts, I needed to upgrade the printer with a hardened steel extruder and nozzle. The combination of the hardened steel extruder and the 0.4mm Hotend assembly cost a total of $55, which is well worth it to me to give my P1S additional capabilities to print glass-filled and carbon-filled materials. In the upgrading the P1S extruder and Hotend section of this video, I will show you briefly how I swapped out the stainless steel parts for the hardened steel parts in the P1S. I decided to print the Death Racer's drive chain parts, including a set of track wheels, motor frame, and the drive gear, and they turned out perfect. I did use a brim and support to give me the best chance of success, and there was no warping of any of the parts for either the X1C or the P1S parts, and the quality was excellent from both printers. Once again, I couldn't see a difference in the quality between the two printers. Okay, to get even more wild and crazy, I decided to go ahead and print additional Death Racer parts on the P1S using the ABS glass-filled filament. I printed the left and right motor frames, the main frame, and the frame cover plate. They all turned out fantastic. There was some slight warping of the main frame cover plate, but that was after the part was printed, and it cooled, and it's due to being such a large, thin part. Now, do you want to get totally nuts? How about printing a nylon carbon-filled part? Nylon is very susceptible to warping, and it's very sensitive to absorbing moisture. So, as recommended, I placed a spool of the nylon CF into a filament dryer at 70 degrees C for 12 hours. Then I printed the same pipe wrench designed by 3dprintedhardware.com, first on the X1C, then on the P1S. For the X1C part, The hook jaw and nut printed excellently. However, the main body started to warp at the end of the print. I had nothing to lose, so I went ahead and loaded the nylon carbon-filled filament onto the P1S. However, I received this error message even after I swapped out the stainless steel extruder and Hotend with the hardened steel versions. I thought that the P1S would recognize the hardened steel Hotend. However, what I learned is that I needed to go into the P1S printer screen and manually change the nozzle type to hardened steel in the menu. Even though I've been printing for over a year and a half, I've always been using hardened steel hotends in all my various printers, so I never had a need to change out a stainless steel hotend. So, I learned something new today. Now, let's see how the P1S was able to print the carbon-filled nylon pipe wrench. It actually turned out great, with no warping, so it was really better than the X1C. In the past, I have found it a challenge to print carbon-filled nylon because it is such a sensitive material to warping. So, to summarize the parts quality section of this video, based on my experience, the P1S rivals the high-quality printed parts of the X1C. I really can't see any significant difference between the print quality of the two printers. Now, let's compare the main features of the P1S and the X1C. There are a lot more things that the P1S and the X1C have in common than their differences. So first, let's quickly cover the features that they have in common. Overall printer dimensions are identical between the two printers, 389 millimeters by 389 millimeters by 458 millimeters high, and that's without the AMS unit. Both printers weigh 14 kilograms or 31 pounds. They have identical print volume of 256 by 256 by 256 millimeters. They are both fully enclosed Core XY printers. They both have the same internal structure. However, the X1C has metal and glass panels and doors, while the P1S has plastic and glass panels doors. They both have a maximum hot end temperature of 300 degrees C. The X1C and P1S both have a maximum speed of 500 millimeters per second and a max acceleration of 20,000 millimeters per second squared. They both have a filament runout sensor and a chamber fan with a carbon filter. Both have a nozzle wipe feature. Both have a multicolor filament / multi-material capability when using the Bambu Lab AMS, which is the Automated Material System unit. And they take advantage of the Bambu Lab RFID tags that are in the bamboo filament spools that allow the AMS to recognize the color and amount of specific materials on each spool. Both come with an auxiliary parts cooling fan and a textured PEI build plate. Both printers work with the Bambu Studio Slicer and the phone app, the Handy. Both printers print wirelessly using the Bambu Studio or Handy phone app. They both have auto bed leveling, Z-axis offset, power loss recovery, and an internal LED light. They both can be set in LAN mode, which allows you to print directly to your printers via your network. You can print the following filaments on both printers: PLA, PETG, TPU, ABS, ASA, and you can print carbon or glass-filled polymers on both printers, but you will need to upgrade the P1S to a hardened steel extruder and hotend for about $55. Now, let's get into the differences between the printers. The X1C has a nice 5-inch color LCD touchscreen to communicate with the printer. However, the P1S only has a 2.7-inch mono display that's not particularly user-friendly. They both have cameras. However, the X1C has a high-resolution 1080 pixel camera, while the P1S only has a low-resolution 720 pixel camera. The X1C comes with a hardened steel extruder and hotend for carbon-filled and glass-filled polymers. However, the P1S ships with a stainless steel extruder and stainless steel hotend. And as I've mentioned before, the good news is that you can upgrade the P1S by installing a hardened steel extruder and hotend for about $55. I show you how to perform this upgrade in another chapter of this video named Upgrading the P1S Extruder and Hotend. File storage memory is different between the two printers. For the X1C, it has 4 GB of internal memory. plus the removable micro SD card, while the P1S only has memory using the removable micro SD card. The maximum build plate temperature for the X1C is 110 degrees C. However, for the P1S, it's 100 degrees C. The X1C has LiDAR, which provides a filament flow calibration, first layer inspection, and spaghetti detection. However, the P1S does not have this feature. Now let's compare the unboxing and setup of the two printers. I bought my X1C approximately a year and a half ago, and I just bought my P1S a few weeks ago. And I was amazed at how similar the unboxing and setup was for the P1S compared to the X1C. If you are interested in my detailed unboxing and setup of my X1C, I will leave a link for that video in the description below. For the P1S, I easily removed it from the outer box and removed the various protective packaging. I removed the accessory box from the printer, and then I removed the two screws to allow me to lift the AMS, which is that automated material system, out of the printer. Then I removed the 4 screws that were holding the AMS packaging and removed that. Next, I removed the packaging from the tool head and the foam from the filament chute. Next, I attached the AMS to the printer by connecting the Teflon tubing and 2 electrical cables, one a 4-pin, the other a 6-pin. Then I attached the external spool holder. The next important step is to remove the 3 screws that hold the hotbed to the printer. Then I attached the 2.7-inch mono screen. I turned on the printer and connected the printer to the Bambu Handy phone app. I scanned the QR code and binded the printer to my Bambu Lab account. I followed the screen prompts to perform the initial calibration procedure. I opened up the AMS and removed the desiccant from the plastic packaging and reinserted the desiccant packs back into the AMS. For my X1C, I 3D printed several upgrades to my AMS to hold reusable desiccant. So I'm going to do the same thing for my P1S. I have included a link to my video titled The 10 Best Upgrades to Your Bambu Lab Printer that includes these upgrades along with several other really helpful upgrades in the description below. Then I loaded some Bambu Lab filament into the AMS. Since the Bambu Lab filaments have RFID tags, the AMS automatically recognizes the type of filament and how much is remaining on each spool. The next chapter of this video covers how to upgrade the P1S extruder and Hotend to hardened steel. To install the hardened steel extruder and hardened steel Hotend, first remove the tool head cover. Then loosen the screw that holds the filament cutter and lower the lever out of the way. Then loosen the 2 screws holding the Hotend and unplug the 2 wires from the tool head and remove the Hotend. Remove the Teflon tubing from the extruder. Then remove 3 screws, unplug the extruder assembly and remove it from the tool head. Remove the 4 screws from the extruder assembly and remove the stainless steel extruder and replace it with the hardened steel extruder. Reassemble the extruder cover to the extruder using the 4 screws. Reinstall the extruder into the tool head using the 3 screws and reattach the extruder cable to the tool head. Then reinstall the Teflon tubing to the extruder. Next, install the hardened steel Hotend into the tool head using the 2 screws and reattach the 2 cables to the tool head. Reattach the filament cutter using the screw you previously removed. Reattach the tool head cover plate by reattaching the cable and snapping the cover in place via the magnets. Go to the printer screen and toggle to the 3rd icon on the left side. Click on Accessories, then click on Nozzle. Choose hardened steel 0.4 millimeters. Then return to the main menu and you're done. Now let's compare the cost of the 2 printers. As of the making of this video, December 2024, Bambu Lab is currently having an end-of-year sale on all their printers. The Bambu Lab X1C combo with the AMS unit is on sale for $1,299, and the P1S combo with the AMS is on sale for $799, a price difference of $500 versus the X1C. Now, if you want the P1S to have the capability to print carbon-filled or glass-filled polymers, you will need to spend $55 for a hardened steel extruder and Hotend, so the net price difference would be $445. Now, let's go to my final summary and recommendations. Overall, I am very impressed with the quality of the prints I made on the Bambu Lab P1S, including prints made from ABS and carbon-filled nylon. And I consider the print quality to be equal to the quality from the X1C. So, assuming that you spend the $55 to upgrade the extruder and Hotend to hardened steel, so you have the capability to print carbon-filled or glass-filled polymers, then you have to ask yourself if the additional $445 for the X1C is worth the added features of the X1C. So here is a brief summary of the X1C added features that the P1S doesn't have. Number one, the 5-inch LCD screen versus the P1S 2.7 mono screen. Number two, the X1C 1080 high-resolution camera versus the P1S 720 low-resolution camera. Number three, X1C has 4 GB of internal memory storage. Number four, the X1C has a maximum build plate temperature of 110 degrees C versus the P1S at 100 degrees C. And five, the X1C LiDAR, which provides a filament flow calibration, first layer inspection, and spaghetti detection that the P1S does not have. If you were only going to buy one printer and you have the budget, I think the X1C is the best printer to buy due to everything I've covered in this video. If you have more of a limited budget, and/or if you're considering maybe eventually purchasing multiple printers, then I think the best value for your money is the P1S. I don't think the 5 benefits I list above for the X1C are worth the $445 more that you would pay for an X1C versus a P1S. When I bought my X1C about 1.5 years ago, it was my first FDM printer, and I wanted the best printer available. I wanted to be able to print right out of the box without having to fiddle with the printer to make it work. So that's why I chose the X1C. Also, 1.5 years ago, the P1P and P1S printers didn't even exist. Knowing what I know now about the high print quality of the P1S, my future printers for my 3D print farm will be the P1S, because I think that is the best value for my money. What do you think? Which Bambu Lab printer would you buy? Let me know in the comments below. If you'd like to see my 10 best upgrades for your Bambu Lab printer video, which has over 365,000 views at this time, that link is here. Thanks for watching. Bye!